James Webb Space Telescope has never seen the surface of this planet. It has never photographed its clouds, never mapped its oceans, never looked across its horizon. In fact, it has never seen the planet at all. And yet today, scientists can argue about what lies beneath its sky. Not because they have more pictures, but because they have only one, a picture made entirely of missing light. That is the mystery of K2-18b. Not whether it could support life, not whether it hides an ocean, but how a world nobody has ever seen became one of the most debated planets beyond our solar system. Everything began during a routine transit. As the planet crossed in front of its small red star, almost all of the starlight continued toward the James Webb Space Telescope. Almost. A tiny fraction skimmed through the outer edge of the planet's atmosphere first. During that brief journey, something happened. Certain wavelengths disappeared. Not because the telescope failed to detect them, because the atmosphere absorbed them before they could escape into space. Those missing wavelengths became the only direct evidence Webb collected about this distant world. Hold that idea for a moment. One invisible planet. One atmosphere. One thin beam of starlight. It should have described one world. Instead, it created two. Two remarkably different planets emerged from exactly the same observations. In one, an immense liquid ocean lies buried beneath a thick hydrogen atmosphere. In the other, that ocean never exists. The atmosphere simply grows deeper, hotter, and denser until it becomes an enormous envelope of gas. Both agree with the evidence. Both explain what Webb observed. Only one can represent reality. For now, no one knows which. The telescope never saw either world. It only saw their atmosphere. For the first time, the atmosphere itself becomes the center of the investigation. Not because it's the destination, because it's the only doorway leading toward the planet below. Now look at what Webb actually received. A thin line stretches across the screen. Small points sit above it. Others fall below. Each one is surrounded by a narrow uncertainty bar. Together they form the atmospheric fingerprint of this distant world. This isn't a photograph. It isn't an artist's impression. It's the closest thing we have to a direct observation. Every point began as starlight. As that light passed through the atmosphere, some wavelengths continued almost unchanged. Others quietly disappeared. The atmosphere removed them. What's missing became the fingerprint. Leave it exactly where it is. One dip appears where methane absorbs infrared light. Another marks carbon dioxide. Farther along, the signal expected from ammonia is surprisingly weak. The graph doesn't explain why. It doesn't suggest an ocean. It doesn't suggest a deep hydrogen world. It simply records what arrived at the telescope. Every point carries uncertainty. Even so, the overall pattern remains remarkably consistent. Measure it again. The fingerprint barely changes. Nothing here has been imagined. Nothing here has been reconstructed. This is the evidence before anyone begins telling a story about the planet. Look at it one more time. Methane is still there. Carbon dioxide is still there. Ammonia is still unexpectedly scarce. Everything that follows must explain those three observations. Nothing more. Nothing less. Now leave every measured point exactly where it is. Instead of changing the evidence, change the planet. A smooth curve settles across the fingerprint. It follows the methane feature, crosses the carbon dioxide absorption, passes through the weak ammonia signal. The fit looks convincing. Now let the planet appear beneath it. Clouds drift across a vast hydrogen sky. Far below them lies an immense liquid ocean, hidden from direct view. For the first time, the world feels almost familiar. Not Earth-like, but understandable. In this reconstruction, the weak ammonia signal has a simple explanation. The ammonia doesn't remain high in the atmosphere. It dissolves into the ocean below. Methane stays. Carbon dioxide stays. Ammonia slowly disappears from the upper layers. Return to the fingerprint. Nothing has changed. The same 3 clues are still there. Only now they seem to belong to a single, coherent world. The atmosphere becomes easier to imagine. Starlight enters from above. It passes through hydrogen, then methane, then carbon dioxide. Each layer quietly removes a different part of the light before the rest continues toward Webb. The fingerprint no longer feels like an abstract graph. It begins to feel like the shadow of an invisible atmosphere. For a while, this picture seemed to explain everything. A hydrogen world, a hidden ocean, an atmosphere behaving exactly as the observations suggested. It looked less like a hypothesis and more like the planet itself. The atmosphere hasn't changed. Only the picture of the planet has. Leave the fingerprint exactly where it is. Now remove the ocean. The measurements don't move. Not one point. Not one uncertainty bar. Only the world beneath them begins to change. A new curve settles across the same fingerprint. It reaches the methane feature, crosses the carbon dioxide absorption, passes through the weak ammonia signal. It fits just as comfortably, but the planet below looks nothing like the first. The clouds remain. The hydrogen atmosphere remains. Everything beneath them is different. Instead of ending at a hidden ocean, the atmosphere keeps going. Pressure rises. Hydrogen grows denser. Temperatures climb. The gas becomes so compressed that the boundary between atmosphere and interior begins to blur. The familiar ocean disappears. In its place is something far stranger. A world with no accessible surface at all. Return to the evidence. Nothing suggested this. Nothing ruled it out. The fingerprint never promised an ocean. It never promised the absence of one. It only recorded the atmosphere crossing the star. Everything below that thin outer layer has always been an interpretation. That realization changes the investigation. The question is no longer, what kind of planet is this? It becomes, how much of this planet can Webb actually see? The answer is surprisingly little. The telescope never looked beneath the clouds. It never measured the crushing pressures deep inside the atmosphere. It never reached the hidden interior. Its observations stop at the narrow shell where starlight passed through the planet's sky. Everything deeper must be inferred. Place the two worlds side by side. One hides an immense ocean. The other never reaches liquid water. Both begin with exactly the same atmosphere. Both explain the same fingerprint. Both survived the same observations. The disagreement isn't happening because scientists saw different data. They didn't. They're looking at the same evidence. They're disagreeing about everything the evidence cannot directly show. That is a very different problem. Look back at the weak ammonia signal. Nothing about it has changed. At first, it seemed to favor the hidden ocean. The idea was simple. Ammonia dissolves into water. Less ammonia remains in the upper atmosphere. The fingerprint makes sense. But the same observation can emerge another way. Powerful circulation pulls atmospheric gases downward. As they sink into hotter regions, pressure and temperature trigger new chemical reactions. When those gases rise again, much of the ammonia is already gone. The upper atmosphere ends up looking almost exactly the same. No ocean required. The evidence hasn't changed. The explanation has. For the first time, the atmosphere stops behaving like an answer. It becomes a test. Every new idea must survive the same 3 clues. Methane, carbon dioxide, very little ammonia. Anything that cannot explain all 3 is eliminated. Anything that can remains alive. The fingerprint doesn't tell scientists which planet is real. It tells them which planets are still possible. And that is a far more difficult kind of discovery. Keep the fingerprint on the screen. For a long time, that was enough. If a model matched the observations, it remained a serious possibility. Today, that's no longer enough. Matching the data is only the beginning. Now every surviving world faces a second test. Not against the telescope. Against physics itself. Imagine pressing play. The atmosphere is no longer frozen. Starlight is gone. The winds begin to move. Radiation pours in from the star. Molecules collide thousands of times every second. Heat flows upward. Gas sinks. Gas rises. The atmosphere never stops changing. Yet somehow, after all that motion, it still has to produce the same fingerprint whenever the planet crosses its star. Day after day. Orbit after orbit. Year after year. Return to the weak ammonia signal. It has quietly become the hardest clue to explain. In the ocean world, the answer seems straightforward. Ammonia dissolves into the water below. The upper atmosphere is left depleted. The fingerprint follows naturally. But the deep hydrogen world offers a different answer. Ultraviolet light breaks ammonia apart high above the clouds. Powerful circulation carries gases downward. Deep inside the atmosphere, increasing temperatures drive new chemical reactions. By the time those gases return to the upper atmosphere, much of the ammonia has already been transformed into something else. The visible atmosphere ends up looking almost identical. The fingerprint never notices the difference. Return to the 2 worlds. They no longer compete only against the observations. They compete against everything scientists know about atmospheric chemistry. Pressure, temperature, circulation, thermodynamics. Every successful explanation must satisfy all of them at the same time. One by one, some ideas begin to struggle. Not because Webb discovered new evidence, because the old evidence keeps asking harder questions. That is how the investigation quietly changes. At first, scientists asked, can this model explain the fingerprint? Now they ask, Can this model continue explaining the fingerprint without breaking the laws of physics? Those are not the same question. One asks whether a picture looks convincing. The other asks whether nature could actually build that world. That shift changes everything. Independent research groups begin testing the same observations from different directions. Different assumptions. Different atmospheric models. Different chemical simulations. Again and again, many of them arrive at a similar result. A deep, hydrogen-rich world naturally reproduces the atmosphere Webb observed using processes already expected inside such a planet. The hidden ocean hasn't disappeared. It hasn't been disproved, but it has become increasingly difficult to require. Notice what just happened. The telescope never eliminated the ocean. Physics began doing it instead. The observations stayed exactly where they had always been. Only the range of surviving explanations became smaller. The fingerprint never grew more informative. The theories surrounding it became harder to defend. Return to the fingerprint. Nothing about it has changed. Not a single point. Not a single wavelength. The graph you've been looking at since the beginning is exactly the same graph. Only now, it no longer looks the same. At first, it seemed to describe a planet. Then it seemed to describe two. Now it describes something else entirely. A boundary. Everything above this line was observed. Everything below it had to be imagined. That's easy to forget. The reconstructions feel real. The oceans, the clouds, the deep hydrogen world. They look like discoveries. They're not. They're explanations. Some may survive. Some won't. The fingerprint doesn't care. It will still be here, waiting for the next idea to face the same test. James Webb has still never seen this planet. Not its oceans. Not its clouds. Not whatever lies beneath them. It has only seen a thin ring of atmosphere crossing a distant star. And somehow, that was enough to transform an invisible world into one of the most debated planets we've ever found. The atmosphere never told us what the planet is. It told us where certainty ends. Everything beyond that line is still waiting to be discovered.